Before getting onto the proof that the one-time pad is secure, I want to do a brief review of probability. If you feel very confident that you understand probability well, it's fine to skip this section. But I think for many students it will be helpful to review probability, and for some this will be new. It's not necessary to have a lot of background in probability entering this class, but we will certainly be using it in cryptography. So to talk about probability, we need to think of sets of outcomes. We'll use omega to represent the set of all possible outcomes. This is sometimes known as a probability space. And for a simple example, if we think about flipping a coin, omega is the set of the outcomes we could get. We could get it to land heads, and we'll call that H, or we could get it to land tails, and we'll call that T. If our probability space has a uniform distribution, that means each outcome has equal probability. And we can write that as a probability using P as our probability function. So P is a function that takes as its input some outcome, and it maps that to a real number between 0 and 1. 0 would mean that event never happens. 1 would mean that event always happens. So if we assume a fair coin with a uniform distribution, well, then the probability that we get heads is equal to 1/2, and the probability that we get tails is also equal to 1/2. So that's how we think of mathematical coins, and we hope to have mathematical coins to use in our crypto systems. Real coins aren't so perfect. So let's assume instead that there are 3 possible outcomes. Now our probability space will be heads, tails, and edge. The edge outcome does not happen frequently. And we'll make the probability distribution, so the probability of heads is 0.49999. The probability of tails, we'll assume our coin is still fair, that the probability of tails is equal to the probability of heads, which is 4 followed by 4 nines. Is that enough to determine what is the probability of edge, the outcome E? So I've given you 2 of the probabilities. Can you determine what is the probability of the third possible outcome, which is landing on the edge denoted by E?